Okay, this is sample test 2. Number 1, f of x equals negative 5x minus 1, h of x equals negative x plus 5. So you're going to find f of h of 1. So f of h of 1, which means that you're going to find f of h of x, and then you're saying that x equals 1. So this is step A and then step B. So step A. For this part to work out, you're going to say that this entire function right here is going to become my x, and we're going to substitute it into the f of x. So it's going to be f of negative x plus 5 equals negative 5x minus 1. And that entire function is going to represent x. So when I expand it, I'm going to have negative 5, negative x plus 5 minus 1. And then I'm going to distribute the negative 5 into the parentheses. So I'm going to have 5x minus 25 minus 1 equals 5x minus 26. So from here, now you can substitute the x for the 1. So we're going to bring this all together. So f of h of 1 equals 5x minus 26. You're saying that this is going to be the new x. So equals 5 times 1 minus 26 equals 5 minus 26 equals negative 21. That's your solution for f of h of 1. Okay, Bob owns a watch repair shop. He has found that the cost of operating the shop is given by c of x equals 3x squared minus 228 plus 68, where c is the cost and x is the number of watches repaired. How many watches must he repair to find the lowest cost? So x equals number of watches, and then c equals the cost. So that's the money. Let's see. I know I'm trying to find the vertex, which in this case is going to be the minimum, because this is a increasing parabola. I know it's positive on both sides because the leading coefficient is positive. And I know it's a parabola because of the exponent of 2. So you need to find the vertex. The vertex formula is negative b over 2a, and then substituting that into the cost formula. So that's going to give you your vertex, which is also your minimum. The first thing we need to do is find this negative b over 2a. So this is actually the x variable. Negative b over 2a. It's the coefficient. I know that a equals 3. Zoom in so you can see that. This right here is a. And negative 228 is going to be b. Okay, so from here, we're just going to substitute. So x equals negative 228 over 2 times 3 equals 228 divided by 6. That equals 38. So with that 38, we know that that's going to be 38 watches, and then we're trying to find the cost. So we're going to say C of 38 equals 338 squared minus 228 times 38 plus 68. So then when we put this in the calculator, you're going to get negative 4,264. And that's going to be the lowest cost. So again, let's define it again. This was the number of watches, and this was the cost. So if we put it all together, I have 38 watches will give me the lowest cost of 4,264. And if we look at our multiple choice, I get 38. For the functions f of x equals negative 6x plus 9 and g of x equals 3x plus 9, find the following. F g of x and its domain, that's A. B is g of f of x in its domain. Okay, so what's important here is it wants the answer simplified and in interval notation. So basically you need to see if there's any part of the expression where it's undefined. Okay, so this should be fairly straightforward. So f of x equals negative 6x plus 9. G of x equals 3x plus 9. Let's work on A first. So f of g of x equals f, and g of x is going to be nested into f. So that means this entire function is going to be substituted for the x. So here's what it looks like. It goes f of 3x plus 9 equals negative 6x plus 9. Again, this entire expression is going to be substituted for the x. So I get equals negative 6 times 3x plus 9 plus 9. You're going to distribute the negative 6, negative 18x minus 54 plus 9. And then from here, you're going to get negative 18x. And this is going to be minus 45. So f of g of x equals negative 18x minus 45. So what happens here is that if I graph this, I know it's going to be a linear function, and I know that nothing's going to stop it. And I know that this right here will be negative 45, comma 0. For the functions f of x equals negative 6x plus 9 and g of x equals 3x plus 9, find the following. A is f of g of x in its domain, B, g of f of x in its domain. Okay, so what I highlighted here was it wants your answer to be simplified and an interval. This is for part A and part B. So let's go ahead and get started. All right, so first thing that we need to make sure we understand is the composite function. So again, this is another composite function. That means that you're going to take whatever g of x is and nest it into f for the x. So it's going to look like this. F of g of x means 3x plus 9. So this entire expression or function goes where I see the x. And here's what it looks like when we're setting it up. So then, again, this entire expression I'm going to substitute for the x. So this is going to equal negative 6 times 3x plus 9 plus 9. You're going to distribute the negative 6 equals negative 18x minus 54 plus 9. You're going to collect like terms, equals negative 18x minus 45. So that's f of g of x. So that's what that answer is. Negative 18x minus 45. And then the domain. So the domain is pretty simple since it's interval notation. Domain, basically for this function, it doesn't have an any area where it's undefined. So if I try to graph this, I know that it's going to be a negative slope, and I know I'm going to have a negative y-intercept. So the graph is going to be something like this. There isn't anything stopping it, so it is not undefined. So in your interval notation, it's going to be negative infinity, comma, positive infinity, because it's a line, negative infinity, comma, positive infinity. So this is linear, and it is not undefined. You kind of assume the same thing with part B. So let's do it again. So part B, we have g of f of x, which means that the f of x is going to substitute it wherever I see the x and the g. So it looks like g of negative 6x plus 9 equals 3x plus 9. This entire expression will be substituted for the x. So that's going to equal 3 times negative 6x plus 9 plus 9. I'm going to distribute the 3, negative 18 plus 27, negative 18x plus 27 plus 9. That's going to give me negative 18x plus 36. And again, this is a linear expression. So if I graph this, I know I'm going to have a negative slope. And I know that my y-intercept is going to be at 36. So it's going to be something like that. And I know that it's not undefined. So let's go ahead and answer part B. Part B is going to be negative 18x plus 36. And my domain is going to be the same thing, negative infinity to positive infinity in interval notation. Number 4, use the given table to evaluate each expression in parts A and B. Okay, this is my table. A is f plus g at 2, f minus g at 4, f times g at negative 2, and f divided by g at 0. Okay, so these are just operations. And these numbers right here are your x's. Okay, so f plus g of 2. So at 2, I'm going to have 11 plus negative 4. So this is 11 plus negative 4. My simplified answer is going to be 7. F minus g at 4. So that's going to be 14 minus 8. So it's 14 minus 8. My simplified answer is 6. F times g at 2, or negative 2. So it's 0 times 4. That's 0 times 4. My simplified solution is 0. And lastly, find f divided by g at 0. Select the correct choice below if necessary. Fill in the box to complete your answer choice. Okay, so at 0, I have 7 divided by 0. So 7 divided by 0. This is going to be undefined because you cannot have a 0 in a denominator. Okay. Number 5, find the correct end behavior for the given polynomial function. P of x equals negative 2x to the 6th plus 5x to the 5th and negative x squared minus 6x plus 3. So the first thing you need to do is find the leading term. Then you need to determine the degree. The same thing for the degree as the exponent. We need to see if it's even or odd. And then you need to look at the leading coefficient. And when you're looking at the leading coefficient, you're looking for what's positive and what's negative, because that's going to determine the arrows, like if they go up or down. So leading term in this case is negative 2x to the 6th. My degree, this is my degree. I know that it's an even number, so it's going to be an even function. So we're also looking for leading coefficient. That's this right here. I know that my leading coefficient is negative, so my end behavior is going to be down on the left and down on the right. Answer is A. Okay, number 6, John owns a hot dog stand. He has found that his profit is represented by the equation P of x equals negative x squared plus 70x minus 77. And P is the profit in cents, and X is the number of hot dogs. How many hot dogs must he sell to earn the most profit? Okay, so I know again that this is going to be a parabola. And I know that my parabola is going to be a decreasing parabola because of that negative in front of it. I know that I need to find a maximum. So we're looking for the vertex again, and we're looking as a maximum. Okay, so X equals a number of hot dogs, and P equals profit. So I have X comma P. I'm looking for the maximum profit or the most profit. So I know that my vertex is going to be X negative equals negative B over 2A. I know it's going to be negative B over 2A, and then P of negative B over 2A. Okay, so P of X equals negative X squared plus 70X minus 77. A equals negative 1, B equals 70. So X equals negative B over 2A, negative 70 over 2 times negative 1. So I get negative 70 over negative 2, which equals 35. So X equals 35. And then we want to know the profit. So how many hot dogs does he have to sell to find the most profit? So let's just substitute this in just to see what it looks like. So I'm going to get negative 35 squared plus 70x x, or 70 times 35, excuse me, minus 77. And if I put all that in my calculator, I'm going to get P of 35 equals 1,148. Again, the question is asking the number of hot dogs he has to sell. So 35 is the number of hot dogs. So I get 35, comma, 1148. So that's 35 hot dogs. Okay, the answer is B. Find g of f of negative 13 when f of x equals x minus 2 divided by 3 and g of x equals 9x plus 5. So f of x equals x minus 2 divided by 13. G of x equals 9x plus 5. This entire expression is going to be where the x is because it's g of f of negative 13. G of x minus 2 divided by 3 equals 9x plus 5 equals 9 times x minus 2 divided by 3 plus 5. When I have fractions, I want to put the whole number underneath the 1. And when I multiply going across. So it's going to be 9x plus 2, or x minus 2, excuse me. It's 9x minus 2 divided by 1 times 3 plus 5. I know I get 9x minus 2 plus 5 over 3. I know that 3 goes into 9 3 times, so I can simplify that. Equals 3x minus 2 plus 5. Distribute my 3. 3x minus 6 plus 5 equals 3x minus 1. So if I now say that this is my g of f, so now I need to do it by 13. So that means the 13 is going to go where the x goes, equals 3 times negative 13 minus 1 equals negative 39 minus 1 equals negative 40. Your answer choice is going to be A. Number 8 is use a piecewise defined function to find the following values of f of x. So f of x includes all these functions and it only exists in a certain interval. So what I would do is draw a number line and for the x value and where the function is defined. So for f minus 3x, it says if x is less than or equal to 3. So that means on my number line, I have 3. 3 is included, and it's everything less than. So that's going to be everything to the left. So that includes like 0, negative 3, and beyond. So 3x, if 3 is less than x is less than 8. This is a bounded number line. So you have 3 and you have 8. Neither one of these are included, so this is an open area, and then we're just gonna shade in between. So it's all the numbers in between. It's not just whole numbers, it's decimals and everything else. And then you have 4x plus 1 if x is less, if x is greater than or equal to 8. So that means on our number line, we're gonna have the number 8, and this is gonna be closed. Everything over here is gonna be negative, so this would be like 6. Everything over here is gonna be positive, so this would be like 10 and beyond, and it goes to the right. Okay, so now that we have defined our number lines, f of 0, so or x equals 0, you're gonna find out where I have 0. Let's see, between 3 and 8, no. So it's gonna be f minus 3x. So in this case, you're gonna say f minus 3 times 0 is going to be 4. That's your solution. For f of 2, it's still gonna be f 4 minus 3x, so 4 minus 3 times 2 equals 4 minus 6 equals -2. For 4, it's going to be between 3 and 8, because 4 comes after 3. And all of these are negative. So 3 times 4 equals 12. F of 6, it's also going to be for 3x. So 3 times 6 equals 18. And f of 9, that's going to be right in here. So 4 times 9 plus 1 equals 36 plus 1 equals 37. So these are your solutions for the piecewise function. Use a graph to find the value of f plus g at 3. This is saying that x equals 3. So you can make a table, x, f, and g. It basically wants to know if I add those two y values, what am I gonna get? So it's f plus g at the value of x equals 3. So 3 for f is 1, and 3 for g is -1. So 1 plus -1, 1 minus 1 is 0. Answer is C. Number 10, identify the vertex of the parabola. So you're gonna have x equals -b over 2a. You're gonna define this as -b over 2a. And then whatever that solution is, you're gonna substitute into the formula, -b over 2a. So you're basically looking for, this is the formula for your vertex. All right, so instead of the y, I'm gonna change it to f of x. I get 3x squared minus 24x plus 51. I'm gonna define my a and my b. My a is 3, my b is -24. I'm gonna build the x equals negative b, which is -24 over 2 times 3, which is my a. I get 24 over 6, x equals 4. So now you're gonna substitute that 4 into the original equation. So f of 4 equals 3 times 4 squared minus 24 times 4 plus 51 equals 3 times 16 minus, that's gonna be 96 plus 51 equals 48 minus 96 plus 51. I'm gonna get 3. F of 4 equals 3. So you're also saying that y equals 3. If I put this together, I had x equals 4, y equals 3. So I have 4 comma 3. Your solution is D. 11, find f of g of x and g of f of x for the pair of functions and give the domains. F of x equals 13 divided by x to the 4th. G of x equals 18 minus x. So the first thing we're going to do is find the composition and then do interval notation. So when you're looking for the domain, you're looking at x's, and because you have a fraction here and it's looking for domain, I think we're going to have something that's undefined. So that's going to be important. So f of x equals 13 divided by x to the 4th. g of x equals 18 minus x. F of g of x equals f. And this entire expression is going to replace x. So 18 minus x equals 13 x to the fourth. Let's put that in parentheses. That's going to be 13 over 18 minus x to the fourth. So that's my composition. So I have 13 over 18 minus x to the fourth. And that expression's in parentheses. It's important that you put the parentheses right there. So let's look for the domain. So to look at the domain, you're gonna consider the denominator. So it's gonna be the denominator equal to 0. And then you're going to solve for x. That's step 1, step 2. So 18 minus x, all that to the fourth, equals 0. You're going to take the fourth root. Okay, so then you're going to get 18 minus x equals 0. Solve for x, number 2. So it's going to be plus x, x equals 18. So when we're talking about the domain, remember I talked about something that's undefined. When I take an 18 and we substitute it into here, I'm going to get a 0. So this is where it's undefined because that would be mathematically incorrect. So if I do this in interval notation, it's only undefined at 18. So it's going to be a union, negative infinity to 18, union 18 to positive infinity. Okay, so the next one is g of f of x. This should be a lot simpler. So again, f of x equals 13 over x to the fourth. G of x equals 18 minus x. G of f of x. It's going to be g, and then this entire f function will be substituted for the x. So 13 over x to the fourth equals 18 minus x equals 18 minus 3 x to the fourth. You just substitute the whole thing. So that is your composite. So that's going to be 18 minus 3 x to the fourth. The domain. So the domain, you want to go ahead and consider the denominator. So 1, the denominator will equal 0. And then 2, you're going to solve for x. So x to the fourth equals 0. You got to take the fourth root. So those go away and just get x equals 0. And so that's where it's undefined. So when I do the interval notation, it's going to be negative infinity, comma 0, union 0, comma positive infinity. Number 12, the graph to the right is obtained from the graph of g of x equals square root of x by applying several transformations. Describe the transformations and give the equation of the graph. Okay, so let's go ahead and graph g of x equals the square root of x. Let's graph that first. I know that that's going to be 0, 0, 1, 1, And that's what the graph looks like. Okay, so then your blue graph, you want to go ahead and notice that it's upside down. So when it's upside down, that means a reflection. We want to go ahead and graph that and know what this point is, -4, 2. All right, so let's go down all of this. So I know for sure I have a reflection. And because it's upside down, I just want to point out that the reflection is across right here. So when it's a reflection going downwards, that means this is a reflection across the x-axis. What horizontal translation applied to the graph of g of x equals the square root of x before any other transformations would be needed to obtain the graph given? So I know that instead of starting in the origin, it goes to the left. So you would say it translates 4 units to the left. So that's B. What type of stretching or shrinking applied to the graph of g of x equals the square root of x after any horizontal translations, but before any other transformations, would be needed to obtain the given graph? Okay, it doesn't have any stretching, so there's no stretching or shrinking in this graph. Next, what reflection applied to the graph of g of x equals the square root of x after any horizontal translations and shrinking or stretching or shrinking, but before any other transformations would be needed to obtain the given graph? Reflection of g of x across the x-axis, for sure. It definitely has a reflection across the x-axis. Because if it was reflected across the y-axis, it would have gone that way. That the graph would have wrapped around the y-axis. So it doesn't do that. And then what vertical translation applied to the graph of g of x equals the square root of x after all other transformations would be needed to obtain the given graph? Well, you know that it goes up 2 units, so you would translate g of x up 2 units. Give the equation of the graph. So you want to type in the equation. A reflection goes on the outside, so that's your reflection. Square root x. Your units to the left, 4, is going to be represented as a positive. And then your 2 units up are going to be a positive 2. So this right here is your reflection. That right there is your horizontal shift. And that right there is your vertical shift up. Okay, let's go ahead and finish out this page. Number 13, let f of x equals 2x minus 1 and h of x equals x plus 4. Find f of f for -3. Okay, so the first thing you need to do is realize that you don't need the h of x. So let's see, f of x equals 2x minus 1. And then it wants you to find f of -3. So first off, I'm going to find f of x. So that means I'm going to have f of this entire function, and it's going to represent the x. So 2x minus 1 equals 2x minus 1. This entire function is going to represent the x. So that's going to be multiplication. Equals 2 times 2x minus 1. Distribute your 2 equals 4x minus 2 minus 1 equals 4x minus 1. And now we're going to find for negative 3. So that's my f of f. Now I need to find f of x of 3, or negative 3. So equals f times negative 3 minus 1 equals negative 12 minus 1 equals negative 13. And that's your solution. Let f of x equals 2x minus 1, h of x equals x plus 4. I crossed out the h of x because the question is asking for f of negative 3. So f of x equals 2x minus 1. I'm just going to write it twice because we're using it twice. Equals 2x minus 1. So we're looking for f of negative 3. I'm going to do the f of f first. So that means that you're going to take this entire expression and substitute it for x. So it's going to be f of 2x minus 1 equals 2x minus 1. Substitute the entire expression, 2x minus 1 for the x. That looks like 2 times 2x minus 1 minus 1. Distribute the 2 to each term equals 4x minus 2 minus 1 equals 4x minus 3. So that's going to be the f of f. F of f. So now we need to find the f of negative 3. So we have 4x minus 3. With this in mind, this is going to be the x. So the x gets substituted for negative 3. 4 times negative 3 minus 3 equals negative 12 minus 3 equals negative 15. So your solution is going to be negative 15. 14, match the equation to the correct graph. Y equals 2 times x plus 3 squared minus 4. So you have options A, B, and C. Before we look at that, we just need to understand what we're looking at our formula. So this is called vertex form. And vertex form basically means that you have a structure of an equation that's going to help you define your transformations. So the first thing you need to know is that when you're talking about a transformation, you have some meaning when it comes to the variables. The first one is going to be A, and this is going to be a stretch when A is greater than 1. And it's going to be a compression when A is a fraction. Then you have H. This is a horizontal shift, and it can go left or right. And then you have K, which is a vertical shift up or down. And lastly, you have H comma K. When you put those two numbers together, it makes a point, which is the vertex. So let's go ahead and look at our equation. Y equals 2 times x plus 3 squared minus 4. In this case, I can say that A equals 2, H equals negative 3, and K equals negative 4. So I know that I have a stretch I know that I have a shift left, and I know that I have a shift down. And my vertex is going to be h comma k, so that's -3 comma -4. So let's go ahead and look at our answer choices. You first want to find the vertex of -3 comma -4. So I know that I can eliminate A and B because they both open down. And I know that my stretch was 2. So I know my end behavior opens up. Sorry, I know that my end behavior opens up because my stretch was a positive number. Okay. So now we need to find -3, -4 for the vertex. And this is my vertex, which is also my minimum. So you're going to go -3 down 4. So the answer is D. Graph the polynomial function. Factor first of the expression is under factor form. F of x equals x to cube plus 3x squared minus x minus 3. So the first thing you're going to do is you're going to factor. We're going to number 2. We're going to talk about zeros and multiplicity. And then 3, we're going to talk about zeros again. And we're just going to match your zeros. Okay, so let's factor. F of x equals x cubed plus 2x squared minus x minus 3. I'm going to factor by grouping. So the first thing you do is group, take out the GCF, and then you have new groups. Pretty simple. And we're going to group the first 2 terms. It's supposed to be a 3x squared, sorry. And the last 2 terms. Then we're going to take out the GCF. That's x squared. Negative x minus 3, the GCF is minus 1. So now that these match, that's a factor. And then your GCFs are a new factor. What's happening here is that I can factor this again because this is the difference of squares. So I just bring down the first factor, and then I'm going to factor the difference of squares. I know that the signs are opposite. The square root of x squared is x. The square root of 1 is 1. So now I've factored. So let's talk about zeros and multiplicity. So zeros and multiplicity are very specific. And I just want to go over it really quickly. When you have an odd number multiplicity, that's the power of the linear factor. So when you have an odd number, your 0 will cross the x-axis. When you have an even number multiplicity, the 0 will touch the x-axis. So we're going to know that we have a multiplicity. We have odd multiplicity. So we know that they're going to cross the x-axis. So now we're going to solve for the zeros. So x plus 3 equals 0, x plus 1 equals 0, x minus 1 equals 0. So minus 3, x equals -3, minus 1, x equals -1, plus 1, x equals 1. My zeros in numerical order are -3, -1, and 1. So now we're going to find the graph that has those zeros. One more thing that we need to talk about is in this graph, you have a leading term. Sorry to be moving it around. You have a leading term that's positive. So when you have the parent function of x cubed and it's positive, it's gonna fall on the left and rise on the right. So it's gonna fall on the left and rise on the right. So we can eliminate the graphs that don't do that. The graphs that don't do that are, let me just cross it out, B and D. So now we need to find a graph that has our zeros, -3, -1, and 1. So I have -3, 0, -1, 0, and 1, 0. If I look at option C, I have -1, 0, 1, 0, and 3, 0. So we can eliminate C, and the option is A. 16, graph the following function. Use a graphing tool to graph the function. You just really need to make a table. Remember that f of x is the same thing as y. So your scale is from left to right, up and down. It's pretty small. So let's just use the numbers -1, 0, and 1. You always have to have something in the middle, something on the left, and something on the right. So f of -1 equals -11, absolute value -1. So that equals -11 times 1 equals -11. So that's -11. F of 0 equals -11. Absolute value of 0 equals 0. And then F of 1 equals -11. Absolute value of 1 equals -11 times 1 equals -11. So let's go ahead and graph that. So I have -1, -11. I have 0, 0, and I have 1, 11. If you connect the dots, you have a absolute value that's been reflected and stretched. Graph the function f of x, 5x plus 1 if x is less than 0. So this is open, and when it's graphed, it's going to be open on 0. So it's going to be open somewhere on 0, and it's going to be approaching from the negative. And it's a line. And then 5x squared minus 4 if x is greater than or equal to 0. So this is going to be closed, and it's a curve. So I know that if it's a curve, it's going to be close to 0, but it's going to be on the positive side. We don't necessarily need to know the graph specifics other than if it's open and closed, a line, or a curve. So let's look at these graphs. If it's open, it's just like a dot. If it's closed, it's a full dot, like it's a bold dot. It's an outline of a dot if it's open. So we have a line, it's on the negative side, but it's closed. So that is not an option. We have B, we have a line, but it's on the positive side, and I said your line would be approaching from the negative side. So that's not right. we have C. Your line is approaching from the negative and it's closed at 0. You have a curve. Oh no, I'm sorry. It's open at 0. You have a curve that's closed. So C might be it. And then let's look at D. You have a curve approaching from the negative. No, your curve is closed and it's approaching from the positive. So your answer is C. Number 18, graph the polynomial function. Factor first if the expression is not factored. This is in factored form, so that helps. And then we're just gonna look at your multiplicity. So let's look at your zeros and multiplicity. Again, with the multiplicity, if it is an odd power, then it's going to cross the x-axis. If it's an even power, it's going to touch the x-axis. We're talking about your zeros. We're going to do all this behaviors. Let's solve for your zeros. Negative 2x, x minus 1 squared, x plus 2 squared. So I know that these two zeros are going to touch the x-axis. So x minus 1 squared equals 0. Square root both sides. X minus 1 equals 0, plus 1, x equals 1. X plus 2 squared equals 0. Square root both sides. So I get x plus 2 equals 0. Minus 2, x equals negative 2. Minus 2x equals 0. Divide both sides by negative 2. X equals 0. So this is going to cross. This is going to touch. Touch. And cross. Let's see. Our power of the exponent, this is a 1. So it's an x to the 5th. But it's a negative x to the 5th. So we also know that the end behavior is going to rise on the left and fall on the right because it's an odd number power. Okay. Sorry about that. So let's find the end behavior that rises on the left and falls on the right. So we can eliminate B and D. And let's talk about the zeros that touch and the zeros that cross. So let's write it down. X equals 0, cross, and then touch, x equals 1, x equals negative 2. So we put those in order. My zeros are going to be negative 2, comma 1. I'm sorry, comma 0, comma 1. So at negative 2, it touches. That's right. At 0, it crosses. And at 1, it touches. At negative 1, this is wrong, so your answer is A. Number 19, y equals x squared minus 2x minus 7. So let's look at the end behavior. And then we're going to find the vertex. So end behavior, this is a positive leading term. So I know that my end behavior is going to rise on the left and rise on the right. So we can eliminate C. Now we're gonna find our vertex. So x equals negative b over 2a. And then we have the point of negative b over 2a and the function of negative b over 2a. So let's go ahead and find that. F of x equals x squared minus 2x minus 7. A equals 1, b equals negative 2. So x equals negative b over 2a. So that's negative 2 over 2 times 1. X equals 2 over 2 equals 1. So f of 1 equals 1 squared minus 2 times 1 minus 7. 1 minus 2 minus 7 equals 8. F of 1 equals 8, so that's 1. It's negative 8, comma negative 8. So we're going to look for that vertex. This is 1, 8. This one is 1, comma negative 8. And this is negative 1, comma negative 8. So my answer is B. Graph the polynomial function. Factor first the expression is not factored. F of x equals x to the first, x plus 3 to the first, x minus 3 to the first, x plus 3 to the third. If I add up all the powers, I have 1, 1, 1, and 3. I know this 6 is an even function, and I know my end behavior is going to rise on the left and the right. I already eliminated C. I know that my zeros are going to be 0, because it's whatever is the opposite here. So x equals 0, x is going to equal negative 3, positive 3, and negative 1. So if I put my zeros in order, I know I'm going to have negative 3, negative 1, 0, and 3. And because I have an odd number multiplicity, this is going to cross, right? That's to the first. Negative 1 is going to cross. 0 to the first, so that's going to cross. And that's to the first, so that's going to cross. So all of these are going to cross the x-axis. And we just need to see which ones do that. Okay, so let's just look at negative 3. So I have negative 3, it crosses. Do I have a negative 1? It does not cross a negative 1. Okay. So that is not an option. A is out. Okay, so let's look at B. Does it cross at negative 3? Yes. Does it cross at negative 1? It's kind of hard to tell. I think it does. Oh, I don't think it does. So this is, does it cross at 0? And does it cross at 3? I want to say right here, it does not cross. Okay. So we know something crosses at 3, something crosses at negative 1, crosses again at 0, crosses again at 3. Your answer is D. Find a polynomial function of least possible degree having the graph shown. Okay, so This means that x equals -5. This is my y-intercept. And this means that x equals 3. So I have f of x, and then I have my polynomial I need to make. I'm going to say +5, x plus 5 is one of the linear factors. So it's going to be x plus 5. And then this is my second linear factor, -3, x minus 3. But we need to know that this crosses, so this is an odd multiplicity. So the first odd number we know is 1, and we know that this, because it crosses. And because this one touches, it's an even number multiplicity. So this is going to be squared. Okay, so before I substitute 0, 9, I need to work this out. So let's see. Let's do the 0, 9 first, and then let's expand it. So f of 0 will equal 9. So 9 equals 0 plus 5 to the first, 0 minus 3 to the second. So that's 9 equals 5 times 9. 9 equals 45. So 9 equals 45a. Divide both sides by 45. A equals 1/5. Okay. So I know that A equals 1/5. And then I have to put that into here. So depending on what is acceptable, we can say that f of x equals 1/5 times x plus 5, x minus 3 squared. So our formula can be 1/5 x plus 5 times x minus 3 squared, or I can expand it. So I'm going to expand it just really quickly so you can see what it looks like. F of x equals 1/5 x plus 5 x minus 3 squared. I'm going to distribute that the 1/5 later. So 1/5 x plus 5. I'm going to expand this first. X minus 3, x minus 3. I have 3x, -3x plus x squared minus 3x minus 3 minus 3, so that's plus 9. At 1/5 x plus 5 x squared minus 6x plus 9. 1/5 x plus 5 times x squared minus 6x plus 9, just so we have it again. So we're going to go like that. So 1/5 x to the third minus 6x squared plus 9x plus 5x squared minus 30x plus 45. 1/5 times x to the third minus x squared minus 21x plus 45. Distribute the 1/5. X to the third over 5 minus x squared over 5 minus 21x over 5 plus 45 over 5 equals x to the third over 5 minus x squared over 5 minus 21x over 5 plus 9. So if I rewrite this up here, it's going to be, or x to the third over 5 minus x squared over 5 minus 21x over 5 plus 9. So either one of those would work. Find the equation of the axis of symmetry of the parabola. Okay, so the axis of symmetry is the x value of the vertex. And you know that vertex equals negative b over 2a. So a equals 3, b equals 30. And this is also equal to the x. So x equals negative 30 over 2 times 3 equals negative 30 over 6. So x equals negative 5. And your answer is C. Number 23, use a given graph to evaluate the following expression. Okay, so A is f plus g at negative 2. So all we're going to do is just kind of make it a table. So A is f plus g at negative 2. So x, f of x, and g of x. Okay, so at negative 2, f of x is 3. No, f of x is 4. And then at negative 2, g of x is negative 1. So we're going to add f plus g. So 4 plus negative 1 is 3. So the answer is 3. And then for b, f minus g at 1. So x, f of x, g of x. So x is 1, f of x is also 1, and g of x is 2. So then it's 1 minus 2, 1 minus 2, negative 1. So equals negative 1. And then C, let's use another piece of paper. So f, g at 0. So this is f times g at 0. X, f of x, g x. Okay, so x is 0. So f is 0, and g is 1. So 0 times 1 equals 0. So that equals 0. And then D, f divided by g at 1. First, we need to know if it's defined. So 1 is x, f of x, g of x. I'm just making the tables over and over. So where x is 1, f of x is 1, where f is 1, g of x is 2, f divided by g, so that's 1 divided by 2, so this is defined. So we know that it's a, and it's defined. 24, for the functions f of x is the square root of x minus 3 and g of x is 5 times x, find the following f of g of x and its domain, and then g of f of x and its domain. The domain is still in interval notation. So this is pretty simple. All right, number 24a. I have f of g of x. So f of x equals the square root of x minus 3. G of x equals 5x. This whole 5x is going to be substituted into the square root. So f of 5x equals the square root of x minus 3 equals 5x minus 3 square root. That's my f of g of x. So it's this right here, square root 5x minus 3. And then it wants the interval notation. So basically what you're going to do is you're going to set what's underneath the radical greater than or equal to 0. So this is the domain. It's 5x minus 3. So plus 3 plus 3. 5x is greater than or equal to 3. Divide by 5. Divide by 5. X is greater than or equal to 3/5. And here's what it looks like in interval notation. So it's saying that x is greater than or equal to 3/5. So that means that it's going to be closed. So it's 3/5, comma, positive infinity. So a bracket, 3 divided by 5, comma, positive infinity. Now for B. So we know that f of x equals the square root of x minus 3. And we know that g of x equals 5x. I'm looking for g of f of x and then the interval. So this entire function is going to be going into x. So it's g of the square root of x minus 3 equals 5x. So this equals 5 times the square root of x minus 3. And then that's basically it. So it's 5 square root x minus 3. And then we need to find the domain. You're going to take what's underneath the square root and set it greater than or equal to 0 and solve for x. Plus 3 to both sides. So x is greater than or equal to 3. As an interval, it's going to be a bracket, 3, comma, positive infinity. So it's going to be 3, comma, positive infinity. 25, the adjacent graph is obtained from the graph of f of x equals absolute value of x, or g of x equals the square root of x by applying several transformations. Describe the transformations and give the equation of the graph. Okay. Since this is like an upside down V, this is definitely an absolute value. So because it's an absolute value, we know that it's f of x. So it's second choice. So f of x equals absolute value of x. Translated blank units to the left. We want to find out what this vertex is. So it's going to be negative 2 comma 4. Translated 2 units to the left, reflected across the parent function for a absolute value is like that. So because it's upside down, it's reflected across the x-axis. And translated 4 units up. So here's the equation. The reflection across the x-axis is going to be a negative out in front of it. So it's negative absolute value x. It moved to the left 2 times, so it's going to be plus 2. It moved up 4 times, and it's plus 4. And that's your equation.